Welcome to another episode of the Distributed Data Show, brought to you by DataStax Academy, where we bring you the latest news and interview technical experts to help you succeed at building large-scale distributed systems.
Okay, so you and Patrick were having this intense conversation about multi-cloud challenges last time. And you know, the problem I had was you were raising all these questions and challenges and not giving us any of the answers.
Right.
So
we didn't give any answers.
Are we gonna start doing that now?
Yeah. So we wanted to raise the answers because that was what we were working toward, is having that list of things that we needed to think about.
Right.
And one of the things that we've been thinking about that I'd like to talk about is, what do you do about networking when you're in a multi-cloud environment?
Okay.
Right.
And that's good. And I think that's where we should start, because you guys were talking about all kinds of things like state management of your within your data tier and you were talking about how do you scale your application, and you were talking about all kinds of stuff, deployments and what have you. But honestly, if you don't have a networking environment set up between those clouds, what do you have? So maybe that is where it starts.
Yeah, and it has to fundamentally, right? Because you get into your cloud provider or whatever, and you go, well, what's the first thing I need to do? Well, you need to know how to connect into where you're going to put resources.
Okay, so that's easy, right?
Sure, I suppose, in relative terms.
Well, I mean, AWS has VPCs and this kind of subnet, and Azure has its own naming stuff. So, like, how do you even begin to unpack and apples to oranges?
That's the inherent thing, because you do have an apples to oranges type of situation with a lot of these providers. You know, at first glance, sometimes you might go in and say, you've signed into GCP and AWS, and you're looking at some of the docs, and you go, okay, I have a VPC here and a VPC here, and then wait, I have to set the subnet up differently, and then I have to route with different resources, and they're called different things. And then you go, oh, wait, I have to go to Azure, and you realize there's not a VPC, so you got to figure out, like, what is that? Obviously, it has a network, but it's a virtual network now. So you have three different contexts and slightly different ways that you need to set all this up. And it's all based around, you know, our standard web-based TCP/IP, you know, OSI layer, et cetera. But when you're allocating these resources in your cloud providers, they're different. And you need to have a way to manage that in a way that you can do that over a period of time. You don't want to just like create this wonderful artisanal bespoke network in one, and then you turn around and I don't know how to put that over here, you know. So
So yeah,
we need some good practices around this stuff.
Right, and you've made it
What do we
sound
use?
like it could be a very manual process to build that kind of stuff up, but that's not gonna really get things done for us long term. Okay, so what are those best practices that are really going to help us have success in managing just even the networking setup and configuration?
Yeah, so the first one, and I say this is as a baseline really, to even getting into cloud space, this should be a baseline. But especially if you're going to go multi-cloud, you have to get your infrastructure written out as code and use whatever tooling that enables you to do that. Whether it's Terraform or maybe Ansible with something else, or whatever combo you have, you got to get that put together. Now, without that, it's just you'll be syncing all the time.
Right. Is that going to give us that common language that's going to help us manage kind of that terminology difference between the different public providers?
Not particularly.
Oh, man.
So you're still managing each of the states, but the thing is it becomes very repeatable.
Yeah.
But when you get to this next practice, what you need to do is you have all your infrastructure managed now as code, so it's repeatable.
Right.
But you need an abstraction above all the clouds to be able to interface with those in a seamless, similar way all the time. And that's where something like Kubernetes or Cloud Foundry or Cloud Foundry on Kubernetes, some of that tooling option comes into play to help kind of bridge all that. So instead of writing weird custom stuff to one cloud provider, even though you have your network built or whatever, and then weird stuff to another one, you can build your images and your Docker containers or whatever, and you can deploy those with Kubernetes. And then that kind of manages your application tier instead of writing proprietary stuff for each of the providers.
Okay. Nice. And something is obviously on fire somewhere.
Yeah. Maybe it's that last Kubernetes deployment.
But it's not our infrastructure. It's someone else's infrastructure that's on fire right now.
Yeah.
So if it's you, stop and check. Stop the video or stop the podcast. Go and check and make sure everything's cool in your envinement, and then come back and
feel the
rejoin
doorknob
us.
first. Don't just plant your hand on it. Be safe.
Exactly. Okay, so you've given me 2 best practices so far: infrastructure as code, and then using that abstraction layer. And then, are there any more?
Definitely.
Okay.
There's probably a lot more.
Yeah,
but the
right,
third
but
big one that I keep thinking about.
You gotta have 3 as the magic number. Give me the third one.
Three is a perfect triumvirate of numbers here. You gotta keep your data needs, your databases, loosely coupled from everything, so that they are managed as the data requirements are needed.
Okay.
So, like if you have a distributed database, we're not quite in a world yet where you just ship that via your Kubernetes deployment or out into a proprietary situation. You want that distributed accordingly across your cloud providers. And then at the same time, if you have other databases, you need to think that through too. Like, how do you make that available in each of your environments and to your applications? You don't want a binding that's going to break. You want something that's loosely coupled that can manage its observability into that database system and things like that.
So what do you mean in terms of this loose coupling? Are we talking about things where our application instances or microservice instances are able to connect to local nodes in a local data center? Is that what you're talking about? Do you mean something else?
So basically what I mean is that you can take your application and have written against appropriate abstractions so that your database, wherever it is, you can just kind of point it in that direction and your application will work with the database. Versus saying, well, prime example, if in your application you write only to one IP and you're tightly coupled to the IP, if the IP changes, like your database has to shift, or say that node drops that IP for some reason within the ephemeralness of the cloud,
I see.
Your whole situation is going to break because of the tight coupling there. But if your application knows how to manage itself when something fails, or like Kubernetes rolls the app, it knows how to reconnect to an appropriate connection point.
Okay. So taking this into like the classic example of using one of our DataStax connectors to connect to Cassandra or DSE, you usually have to provide it a list of connection points, which could be an IP address, or it could be a well-known name. There are different challenges that associate with that, but what we really need is something to where we can reliably provide something to our services or our applications to know how to connect to the database that's not tied to a specific IP. Right. Okay, and there's
so
good
that way
challenges.
You get the dynamic nature on both ends, where you can make some application changes, restart the application, and it can get back in touch with whatever it needs to on the other end. And vice versa, where if the database needs some changes to be made, or you need to roll that, some connection points or whatever variances that come up, you can make those changes and restart things, and it's seamlessly interconnected between.
Okay, that makes a lot of sense. And I guess I will say one of the things that could be a challenge in terms of reconfiguring the state of your application if you have to seed it with a new IP address. One of the good things about the way that the driver has always worked is that if it's able to connect to any node in the cluster, it's able to, through gossip, discover the locations of the rest of the nodes. So it's really a matter of like getting that bootstrapping point that you can connect to. But even that can be hard if you're relying on static IPs.
Well, distributed systems problems, right?
Yes.
So there's always the question of what else is going on. And like with DataStax Enterprise, that's one of the big advantages too, right? Because you can easily span that through the way it's built across your multi-cloud. So it's in the environments you need it to be, whatever is running out in your cloud. So like if you have different types of architectures in your cloud, like services are running over here, some other app services running in this cloud, and that layer is not exactly the same. You can still have the data tier abstracted appropriately, loosely coupled to those things, and be able to have have it wherever you need it in whatever
Okay,
cloud.
so if your application layer is kind of heterogeneous with different applications and services running in different clouds, that the data tier doesn't care
Right.
or matter from that.
It's like, I'm here, I'm available, let's do whatever we need to do.
Right, and because of that core Cassandra construct of the data centers and racks in terms of describing the topology, we've always said it could be a literal data center. It could be a data center in a different cloud provider, and you can have multiple data centers that represent multiple AWS regions, or additionally, different, what do they call it? What does Azure call them, regions?
Yeah, it's a good question. I think the naming actually even changed once.
Then, yeah.
So they flipped it around, but I think it's region and zone and region. I'll have to look that up.
Yep.
That's what documentation's for.
I doubt myself. But again, back to the naming and terminology conventions between these different ones and why we want infrastructure as code.
Yep, exactly. So cool. That's the big three that keep coming up time and time again whenever I'm looking at any type of multi-cloud networking.
Okay.
I'm talking to any customers or people that are looking at moving into a multi-cloud environment. Those three things always come up. So and I often say, these are your three things that as a baseline, you need to get to this point before you move into a multi-cloud situation.
I gotcha. Okay, so I'm gonna commit. I want to be opinionated, like on the spot here. Like, what is your tool selection of choice? You said we need infrastructure as code. You say we need to abstract things. Like, what would you do? At Adron's world, what happens?
Adron's world, my first go-to items are Terraform and Kubernetes.
Okay.
Boom. And like right now, I can go out to a repo that I have on GitHub, and I might have to tweak something just because the connection strings and keys and such aren't going to be the exact same because I always have new accounts to connect to and such. But for the most part, the Terraform configs that I've written out will deploy Kubernetes into an environment, and then I'm set up and ready to go, get my DataStax stuff out there, and I have the appropriate prereqs met to go multi-cloud.
Okay, so that'll get you started.
Yep.
Okay, so you still have some more explaining to do, which we'll leave for maybe a future time.
Or maybe a blog entry or 4.
Yeah, well, blogs, videos, we do it all.
All the stuff.
So thank you. Thanks for sharing the wisdom. More goodness to come on future episodes of the Distributed Data Show. Thanks.
Thank you for joining us again for the Distributed Data Show. We love your feedback, so go to the Distributed Data Show page on DataStax Academy and tell us what you think. You can also find us on the DataStax Academy YouTube channel or find our podcast on iTunes, Google Play, or wherever you get great podcasts. While you're there, make sure and subscribe so you don't miss a single episode.